Hey, it's Mr. Barr, and let's do a lesson on graphing lines. So boom, get over here, get your notebook out. There's my notebook. There we go. Topic is graphing lines. So let's start with that. Graphing lines. Cool, graphing lines. There's our animal, which is a nutria. So let's remember everything about the slope-intercept equation. Y equals mx plus b. Here we go. Graphing lines, slope-intercept equation. Y equals mx plus b. And let's remember everything that we know about this thing. We know about m and b. What do we know about m and what do we know about b? Well, we know a lot about it. We know that m is the slope. We know that it's rise over run. We know that it's the rate of change. We know that it's Liam's move. We also know it's called the unit rate and constant of proportionality. Those two might be new. There we go. Oh, sorry. Slope, rise over run, rate of change, Liam's move, unit rate, constant of proportionality. So that's what we know about the m. What do we know about the b? Well, we know that the b is the y-intercept. We know that it's the starting point. We also know it's Liam's b. And that is what we know about the slope-intercept equation. There we go. So here's how I graph a line in slope-intercept form. I know the top number is the rise, I know the bottom number is the run, and I know that the 4 is the y-intercept. We're going to put this into our notes. So y equals 1/2 x plus 4. Y equals 1/2 x plus 4. I know that this is the rise. I know that this guy right here is the run. And I know that right there is the start. Or the y-intercept, right? Same thing. Cool? So how do I graph this? Well, I put the 4 on the start. I start to rise or fall, I start to run, and I continue the pattern, and I drop more coins. So we're going to get that flow map into our notes. So what's our method here? Box 1. Plot y-intercept. What do I do now? I rise or fall if it's a negative. I then run to the right. And then I just continue the pattern. Plot the y-intercept, rise or fall if it's a negative, run to the right, continue the pattern. Let's graph some stuff. Here we go. Where does Liam want to be on this one? Well, he wants to start at -3. How does he want to move? He wants to go up 4 over 1. Yes, there's a 1 underneath that 4. Where does Liam want to be? Well, Liam wants to be at 0 on this one, doesn't he? Yeah, I know it's not there. You can't see it, but we know there's a 0 right there. Where is it? I'll draw it in for you right now. Right? So he wants to start at 0, and then he wants to go down to right 3. Ooh, this one. Where does Liam want to be, and how does he want to move? Well, let me show you all the invisible pieces. Liam wants to be at 0, and then he wants to go up 1 over 1, up 1 over 1, up 1 over 1. Ooh, how does Liam want to move on this one? Well, Liam wants to start his life at 0, right here, and then he wants to go down 1 over 1, down 1 over 1, down 1 over 1. So let's graph this. Where do I want to start? I want to start at 2. How do I want to move? Up 3, 1, 2, 3, over 2, 1, 2. And right there, I can connect the dots and have a nice line that looks like that. There it is. Where does Liam want to start his life? Well, Liam wants to start his life at -3, which is right about here. How does Liam want to move? So it starts at -3. How does he want to move? He wants to go down 1, right? It's -1 over 1x minus 3. He wants to go down 1 over 1, down 1 over 1, down 1 over 1, which is going to give us a line that looks like that, or something similar to that. Boom. Now we have a different form of a line. This is standard form. We're going to split it into an x and a y equation. We're going to solve for x, solve for y, plot the y-intercept, plot the x-intercept. Let's get this one into our notes. So we're going to graph this. 2x plus 4y equals 8. What we'll do is we'll split it into an x equation and a y equation. Split into an x and a y equation. We'll solve it for x. We'll solve it for y. And then we'll graph the x, graph the y, and connect the dots. So plot the x-axis, or plot the y-intercept, plot the x-intercept, and then connect with line. So I'm changing my flow a little bit. Connect with a line. Split it into two equations, the x equation and the y equation. Solve it for x, solve it for y, plot the x, plot the y, connect it with a line, and you have graphed it. So right here on this one, I would have, I'd split it, I'd have 2x equals 8, 4y equals 8, dividing by 2, x equals 4, dividing by 4, y equals 2. This is your x-intercept, that's your y-intercept. Plot them, connect the dots. This one, don't trip out. Split it up. X equals 8, negative 4, y equals 8. This one's done. We have the x-intercept. Divide both sides by negative 4. Y equals negative 2. You have your two intercepts. Plot the intercepts. Draw the line. Yes, you're going to trip out on this one. I get it. 2x equals 3. 5y equals 3. Dividing by 2, dividing by 2, dividing by 5, dividing by 5. X equals 1.5. 3 divided by 2 is 1.5. And y equals, this would be about a 0.6. Go decimal on it. You can plot decimals. Yes, we're going to talk about move the x, divide by the y, but that'll be another lesson, even though you've learned move the x, divide by the y at this point. Okay, let's graph it. So I can actually do this one in my head. 2x equals 12, so x equals 6. X equals 6. 6y equals 12, so y equals 2. Boom, connect the dots with a line, and you have the graph. Okay, do I have the answer key? Yep, there it is. See my 2 points? There's the graph that goes with it. And that's it. Thanks for watching. Have a good day. Make sure that you have everything that I wrote down. I've got the graph. I've got my flow chart for standard form. I've got my flow chart for slope-intercept form. And I have my my tree map for slope-intercept form. Okay, thanks. That's it.